Now in question number 5, second question, you have to prove CP square minus BP square is equal to 2AP into PB. So you have this triangle, you have to consider the first triangle AC square, because the hypotenuse is here, opposite side is hypotenuse. AC square is equal to AP square plus CP square. Okay, now if you see PC square, you can write CP square as it is and move AP square opposite side. So AC square minus AP square. Okay, AP square move on the other side. Now AC is equal to AB, given in the question AC is equal to AB. So now instead of AC you need to write AB. Okay, so CP square now is equal to AB square minus AP square. Now if you see AB is equal to AP plus PB. Okay, so instead of AB just write AP plus PB. Now whole square, AP plus PB whole square. So just written AP plus PB whole square minus AP square. Okay, so I have written instead of AB I have written AP plus PB. Now you have to open this A plus B whole square. So now I will get AP square plus 2AP PB plus PB square. Okay, this is AP square. Now AP square plus 2AB PP plus PB square minus AP square. So AP square cut, you are left with 2AP PB plus PB square. Okay, now here is a CP square. PB square you have to take other side. This is a PB square, then is equal to 2AP into PB. So now this you are supposed to be proved. Okay, now question number 6, which is again very easy. P is any point inside the triangle ABC. Okay, so I'll draw the triangle again. Your triangle ABC. Okay, now you might not given the diagram. Okay, you might draw it anyway, which is again easy. P is a midpoint, any point, not midpoint, but any point on the in the triangle ABC. Now what they said, and PQ, PR, PS are drawn perpendicular. Okay, so now PQ perpendicular on the AB. So PQ on AB you have to draw like this. PQ on AB perpendicular, that means this will be a 90 degree and this will be a PQ. Okay, then what they said, PQ, PR on BC. Okay, PR on BC. So this is my PR. Okay, this is your PR BC perpendicular. Then last one is the PS on AC. So this will be your PS. Okay, this is your PS on AC side. Now what you have to do, you have to do little bit construction over here. Okay, you have to join this value, this line like AP, PC and BP. You have to join this. Now from here you have to just understand the basic concept. Now you have to consider all 6 triangles. This is your first triangle. Okay, you have to leave one. Then this is a second triangle, leave one. This is a third triangle. Okay, then further this is your fourth triangle, this is your fifth triangle, this is your sixth triangle. Okay, why I am taking this? See, if you see, consider first triangle. So this is your AP is your hypotenuse and Q is a 90 degree. So if you consider AP square is equal to AQ square plus PQ square. Okay, so now AQ square is what? AQ square is equal to AP square minus PQ square. This is your first equation. Then in second triangle PBR, BP is your hypotenuse, so PR plus BR. Again I am taking, see why I am taking AQ here. Okay, the reason I need to prove, I need that on left side AQ square is required. Same way BR. So now here BR square is equal to BP square minus PR square. Then third one is third triangle. Okay, this is your 90 degree. So now CP, PC square. So CP square is equal to CS square plus PS square. Now you require CS square, so you move PS square on the other side. So this is your third equation. Now what happened, you have to add all three, AQ, BR, CS, AQ, BR, CS. Okay, so now what you will get, somewhere you have to add all these six terms, AP, PQ, BP, PR, CP, PS. So these are all your six terms. Same way you have to consider 2, 2, 4, sorry, 4, 5 and 6, these three triangle. Okay, if you consider that, same way you need to do it. What happened in triangle 4, if you see, BP square, BP square is equal to QP square plus BQ square, QP square plus BQ square. Now what you are required here on right side, BQ square. So same way what you need to do, keep BQ square as it is, move the QP square. So BP square minus QP square. Same way in case of 5 and 6. Now if you add all 4, 5, 6, you will get BQ, ASC, RC. Okay, so you need to add this 4, 5, 6, BQ, AS, RC. You will get this result. Now if you see the result of both the equation, final equation, which is 7 and 8, then you can see all the terms are equal. Now like that, AP square, here is also AP square, minus PQ square, minus PQ square, BP square, it is BP square. If you check, verify this, both the terms are equal. So if this right side is equal, then obviously left side is also, you can see, equal. So these both equations are equal. Now question number 7, which is very easy. This is a quadrilateral they were given. They have said angle B, angle D is 90 degree. Prove that so and so. Okay, now simply you have to take these two triangles. Okay, triangle ACD, triangle ACB. So in triangle ABC, hypotenuse will be AC square. AC square is equal to AB square plus BC square. In triangle ADC, again AC square is equal to AD square plus CD square. AD square plus CD square. You have to simply add AC square plus AC square, which is 2AC square. Okay, now you have to add AB square, BC square, AD square, DC square. See, AB square, BC square, AD square, DC square. Now there's 2AC square. What you are looking for? 2AC square minus BC square. You have to simply minus this value. You have to put other side. BC square you have taken left side. So it has been proved. Okay, question number 8. In triangle ABC, acute triangle, basically acute triangle, and AD perpendicular BC. Prove that so and so. Now what I am doing, I have to take again two rectangle. Now here AC square is equal to AD square plus CD square. Okay, in another triangle, AB square is equal to AD square plus BD square. Okay, now you can say here what you can do, AD square. Okay, I'll move BD on other side. So AB square minus BD square. So now what was my first equation? AC square is equal to AD square plus CD square. Now instead of AD square, I'll put it like this. AB square, see, AD square की value is this, so I'll put this value over here. Okay, now AB square minus BD square plus CD square. Okay, now from here now AB square minus BD square plus CD. See, what is CD? CD is what? BC whole minus BD. Okay, so what you can write here, BC minus BD whole square. Okay, now further, AB square minus BD square plus BC square minus 2 BC dot BD plus BD square. Okay, Now just open the bracket. AB square minus BD square plus BC square minus 2 BC BD plus BD square. Okay, you can cut the BD square. Now you are left with is AC square is equal to AB square plus BC square minus 2BC dot BD, which is you are looking for, proved. Okay, question number 9. Here they have given M is a midpoint, okay, and S is a perpendicular to QR. See, now you have to prove PQ square minus PA square is equal to 2QRSM. Now M is a midpoint, so you can say QM is equal to MR. See, this is given, QM is equal to MR. Take triangle 1. Here PR square is equal to PS square plus SR square. Second triangle, PQ square is equal to QS square plus PS square. Okay, now what you are looking for, PQ square minus PR square. You have to simply subtract these two, PQ square minus PR square, PQ square minus PR square. So now PQ square is this QS square plus PS square minus PS square plus SR square. Open the bracket. QS square plus PS square minus PS square minus SR square. Okay, so now here PS square will cut. So you are left with QS square and SR square. Now if you see, the QS is nothing but it is a addition of QM and MS. So just write it down, QM plus MS. Then what about SR? So SR is this. See, this is your SR. So SR is MR minus MS. Okay, SR is what? What is SR? Whole MR minus MS. So MR minus MS. Now you have to use the formula, QM square plus 2 QM dot MS plus MS square. Okay, now subtraction, you have to put it in bracket. MR square minus 2 MR dot MS plus MS square. Okay, now you need to open a bracket. QM square plus 2 QM dot MS plus MS square minus MR square plus 2 MR dot MS minus MS square. Okay, MS square cut. So now you are left with QM square and MR square. So now if you see here, QM is equal to MR, so that also you can cut, QM square and MR square. So you are left with is 2 QM dot MS plus 2 MR dot MS. Okay, now 2 MS you can take common, 2 MS common. You are left with QM plus MR. So if you see, QM plus MR is nothing but it is a QR. So just write it down here, 2 MS dot QR. Okay, so now PQ square minus PR square is equal to 2 MS dot QR. 2 MS that you are supposed to prove. Okay, question number 10. Here you have given triangle PQR, the value given y, here x. Okay, now you have to take first of all triangle PQS, triangle PQS, the bigger one. So triangle PQS is equal to PS square plus PQ square. What, QS square? QS, you can say PQ square, PS square, in triangle PQS, PS square is equal to PQ square plus QS square. Then take triangle, another one smaller one, PQR. PQR, it is a PR square is equal to PQ square plus QR square. Now you can subtract PS square minus PR square. Okay, PS square minus PR square. So PS square is what? PQ square plus QS square minus PQ square plus QR square. Okay, now PQ square plus QS square minus PQ square minus QR square. So you can cut this PQ square. You're left with is QS square minus QR square. Okay, so now QS square you have to keep as it is, QS square minus QR square. So if you see, QR is what? QS minus RS. Okay, so write it down, QS minus RS whole square. So now again QS square minus, just open the bracket, QS square minus 2 QS dot RS plus RS square. Okay, so now you can break it, open the QS square minus QS square plus 2 QS dot RS minus RS square. Okay, so now again this will be getting cut. Now here it is PS square minus PR square. Okay, now here 2 QS dot RS minus RS square. Okay, now if you see, PR is, they are given basically here, see y value given, so RS is equal to PR, because both the case their value is same, so basically this line also same. So RS is equal to PR, so instead of PR, PS square minus RS square. Okay, instead of, I'll write it down RS square. Now 2 QS dot PS minus RS square. So RS square getting deducted, so now you're left with PS square is equal to 2 QS dot PS. Okay, that you are supposed to prove. Question number 10, sorry, question number 11. They have given one triangle, see various value has been given. Now you have to prove that 1 upon a square is equal to 1 upon p square plus 1 upon q square. So now what you have to do, first of all take Pythagoras theorem, PQ square is equal to PR square plus RQ square. Okay, so just apply the value, PQ is nothing but R square is equal to Q square plus P square. Okay, now here something else, you have to try some other method. Now if you consider this triangle PQR, and if you say base is RQ, okay, if this is RQ is the base, then area of this triangle is 1 upon 2 into base into height. So in this case your base is RQ, height is PR. So triangle, area of triangle PQR, area of triangle PQR is equal to 1 upon 2 into base into height. So base is nothing but P, height is Q. So this is your one formula. Okay, now again you have to consider this triangle as a base is PQ. Okay, if you consider this is your base, then your height will be RS. Okay, so now what you can say here, this value is A, this is A given. Now if this is a base, then 1 upon 2 into base matlab R, height matlab A. Okay, so 1 upon 2 R. Now this both the triangle area is common, area is standard, so you can say 1 upon 2 PQ is equal to 1 upon 2 RA. 1 upon 2 PQ is equal to 1 upon RA. Reason, see this is a triangle. In what case 1 you have considered base this, in another case you have considered base this. So In both the case you are finding different value, but area will remain same. So you have to put it equal sign over here. Now 1 upon 2 cancel, PQ is equal to RA. Okay, so now you find value of R is equal to PQ upon A square both the side. So R square is equal to P square Q square upon A square. Now R square is nothing but it is a Q square plus P square. Consider this, we have already taken initially. So P square plus Q square is equal to P square Q square upon A square. Now divide everything with the P square. Okay, so now because you want here in denominator Q square, so now divide by P square. So P square divided by P square Q square, divided by P square Q square. So if you divide P square Q square, you will find, you will reach left with 1 upon Q square. Here P square Q square, you are left with 1 upon P square, which is you are looking for here. And here P square Q square deduct, you are left with A square.